Hello students, today we will discuss about JEE Mains 2015 physics paper. Now we will discuss all the questions one by one. Okay, let us start. Hello students, let us move to the next question, question number 21. It talks about a rectangular loop of side 10 centimeter and 5 centimeter. So loop has length 10 centimeter and breadth is 5 centimeter, carrying a current I of 12 ampere. So just like this, the current is 12 ampere. Here also it is 12 ampere, and so it's placed in different orientations. But the coil is placed in different orientation, as you can see in four options. Now, if there is a uniform magnetic field of 0.3 Tesla in the positive Z direction. Positive Z direction is this. This is your Z. He has taken this X, Y, and Z. So this direction is your positive Z. So here also it is like this. Here also it is like this. Here also like this. Here like this. So in this direction, that is a magnetic field which is 0.3 Tesla. Okay. Now, in which orientations the loop would be in stable equilibrium? The first one is asking about the stable equilibrium, and the second one is unstable equilibrium. So you have two answers, one for stable and another for unstable equilibrium. Now, if you see the options, option 1 says A and B respectively. A and B means whether this is A or this is B. So I'll write this as A, this as B, this is as C, and this is D in fact. So these are A, B, C, D. So whether the answer is A, B or the answer is A, C, like that. So you have to find which one is the correct option. Now, let us see the diagrams. Let us discuss one by one. In the first case, if you see, the diagram is like this. I'm just copying the diagram. Okay, this is the case, and this is your X, this is your Y, and this is your Z, and the magnetic field is in this direction. If I want to write the value of length breadth, then it's okay, although it is not necessary, but still I'll write what is given, that the length is 10 centimeter, the breadth is 5 centimeter, the current is 12 ampere, and the magnetic field is 0.3 Tesla. You can convert this as this area from here. The area is 50 centimeter square, which is 50 into 10 raised to minus 4 meter square. So these are the data given. Now, now you can see that this coil is actually placed in a YZ plane. Okay, and suppose this is a YZ plane. This coil is placed like this. This is your Y and this is your Z, and the current is in this direction. Okay, so if I from my side it is anti-clockwise, so from your side it will be clockwise. So it is anti-clockwise. So if I have now what is to found is for stable equilibrium. For equilibrium, the net force and net torque must be zero. Net force and net torque must be zero. So because it's a loop placed in this, so therefore we have to only find the net torque. The force is obviously zero, so I'm not finding that. I'm just finding the net torque. Now torque is N cross B. Okay, torque is in a coil. If I have a loop, okay, current is I, then the torque is N cross B. This is the torque in a loop. Okay, the torque experienced by a loop placed in uniform magnetic field is N cross B. That we know, mb sin theta. So, M is what? If the coil current is in anti-clockwise sense, then this is the direction of M. This is the direction of M. So this is your direction of M. Okay, B is in whatever direction. Accordingly, we find the torque. Now, if B is in this direction, then both are in the same direction, then it is sine 0 is 0. Now, if this is in this direction, this is YZ plane, YZ. If this is YZ plane, then this is direction of M. But then B is like this, so it is torque is MB. Torque is MB, but torque is not 0. So for that we should have torque 0. So for here the theta between torque and this is 90. So here theta is 90 and torque is MB. It is not 0. But for equilibrium you should have torque, stable equilibrium torque should be 0. So it is not possible. So option 1 is not correct. The option A is not correct. Let us check the other option. If I see the option B, I'll just you can see this is the option number B. Here the coil is placed in XY plane and the orientation is anti-clockwise. So let me draw the diagram once again. This is your X, this is your Y, and this is Z axis. The coil is placed like that. The current is in anti-clockwise sense, and the magnetic field is as usual in this direction B. Now suppose this is my X and this is my Y and this is my Z. The coil is placed in XY and the orientation is like that. Like that. You can see here like this. X, Y and Z like this. So M is in this direction, that is in Z directions, and B is also in the same directions. So now in this case the M and B are in the same direction, so therefore the torque is 0. When the torque is 0, you have that is stable equilibrium. So you have two things. One is that stable equilibrium torque is 0. For unstable equilibrium also torque is 0, but there is a difference. The difference is that if theta is 0 between this dipole moment and this magnetic field, then it is called stable equilibrium. If dipole moment is in this direction, the M vector is in this direction and the B vector is in opposite direction, then the angle is 180 degree. In that case also the torque is 0, but then it is unstable because you slightly disturb that, the whole thing will turn. Okay, so therefore that is unstable equilibrium. But for that moment, when, as long as the angle is maintained 180 degree, that is stable, unstable equilibrium. Now, so here what I'm getting is the theta is 0 degree. So this implies that the torque is MB sine 0, that equals to 0. When the net torque is 0, this is called stable equilibrium. So in this case the coil is in stable equilibrium. So option B is for stable equilibrium. Option B is for stable equilibrium. So for that we have got two choice, that is 3 and 4. So let us solve for the unstable equilibrium. So now I have to see that the C diagram is like this. This is again X, this is Y, and this is Z, and the coil is placed in XZ plane. So now this coil is placed in this plane and the current is clockwise. Okay, you can see here this is the situation. It's clockwise and the current is I in this direction. Now if and again the B is always in this direction, B is not going to change. Now the coil is in XZ plane. Suppose this is XZ plane and it is clockwise, so the dipole moment will be in this direction, but then this is Z axis, so B is in this direction, M is in that direction, so M cross B will be like that, but M cross B is not 0, so this option is not possible. Let us see the other option, D. Again I have to draw the diagram. This is X, This is y, this is z. Now the coil is placed in xy plane, and it is this time clockwise. If this is xy plane and it is clockwise, so I have to find the direction of m by curling my fingers in the direction of the current. So m is vertically downward, but then that is in z direction, but negative z direction. So m vector is in negative z direction, and that is you can say area vector also, no problem with that, because m is I into a ultimately. So the area vector is pointing downward, or m vector is pointing downward in the negative z direction, and the magnetic field as usual is in the positive direction. The magnetic field is in positive direction. So how these two vectors are making an angle, as you can see, this is minus k cap, which is downward, this is plus k cap, which is upward, along the same z line. So the angle is 180 degree. If the angle is 180 degree, again the torque is 0, but then this is called unstable equilibrium. Let me, I hope that you understand this, that why at 180 degree it is unstable equilibrium. Because the situation is something like this. If you have suppose a magnet is there, to understand this I will just take this illustration. Suppose magnet is there, and magnetic field is like this, external magnetic field, it is placed like that. Suppose this is your uh, this is suppose north pole, this is south pole, and this should be the north pole and this is the south pole. In this orientation of the magnet, the force will be in this direction, and the force on this direction, the net force is 0, it is in equilibrium. But then here the angle is 0, because you can see that the m vector is in this direction, the v vector is also in this direction, the angle is theta is 0. So that is the case of stable equilibrium, because it does not rotate. If you slightly disturb it, then also it comes back to like this. But if I reverse the direction of this magnet, I just reverse the direction, that means the north pole is placed here and south pole is placed here, then the magnetic field direction, the magnetic moment, dipole moment will be in this direction from south to north, and the b is as usual in this direction, b is like so. If I find the net force, then also it is in equilibrium, because the force on this will be, the force on south pole will be like this, and force on north pole will be like that. So two forces are acting like that. These two will also cancel out each other. If I apply a force in this direction, then also it will be equilibrium. If I pull it like that, then also it will be in equilibrium. This was that is in equilibrium, but it is unstable, because if I slightly disturb this position, if I slightly disturb this situation I am just drawing here, if you just slightly disturb it, this force will be in this direction, this force will be in this direction. It will have complete rotation. It will have maximum rotation. So, but therefore, this is unstable. Okay, stable means if you slightly disturb from, in this case, if I slightly disturb it, then it will come back to its position. So that is stable equilibrium. That means you slightly disturb it and it comes back to its original position. Here, if you slightly disturb it, it will not come back to its original position here. It will take some other turn. So it will move away from the equilibrium position. It will move away from the initial position. Therefore, this is unstable equilibrium. So finally, the options D for unstable equilibrium and option B that we discussed for stable equilibrium, that is correct. That we discussed B for stable equilibrium and D for unstable equilibrium. So therefore, the choice for this question number 21 is stable equilibrium, B is correct, unstable equilibrium, D is correct. So option number 3 is the correct answer.